Welcome to Gestalt IT.
Hello, my name is Ross Dermott. I'm at Micron Technology, and I'm the vice president of our mobile product line management team. In my team, we're responsible for everything from planning our mobile products to working with our product development teams to design and develop the product. And then we work very closely with our customers in the mobile ecosystem to get the products qualified and ramped into high volume.
And I'm Tom Hollingsworth. I'm an analyst here at Gestalt IT, and I want to thank Ross and the team from Micron for being a part of this interview. Let's jump right in, Ross. I know that a lot of people out there are starting to rely more and more on their mobile devices as a core part of all of their daily interactions with pretty much the world, whether it's communications or ordering food or a number of things. And we've seen a massive increase in the amount of complexity that mobile devices have in the past 5 to 6 years. But we're on the cusp of something even greater than that, and that would of course be 5G and AI. These are both massively transformative technologies that are kind of looming on the horizon as we record this interview, that have a potential to not only disrupt the way that we do mobile space, but also to increase the complexity of those devices far beyond anything we could have possibly imagined. And I know that at Micron, you have a unique perspective on how this looks. So I was wondering if you could kind of tell me and our audience, what are some of the complexity challenges that our mobile device manufacturers are going to face in the coming years that quite honestly could be passed on to the customers unwittingly?
Yeah, Tom, to your point, if you think about what you can do with your phone today, it's absolutely amazing. I mean, we have the ability today to run multiple advanced applications in parallel. We can take incredible images with computational photography, with image sizes, that approach resolutions of 80 megapixels up to 100 megapixels and higher. We can create and manage 4K, 8K content and video streams. And then for the gaming community, you can find phones today that have gaming capabilities that really rival what we've only historically seen in more like desktop platforms. To your point, as 5G and AI continue to penetrate the mobile space, it's just going to advance the capabilities of those handsets, advance the demands on the hardware that go into those handsets. Today and moving forward, handsets have to manage more data, faster data rates. They have to do it concurrently. And that places a lot of demands on the memory and storage that goes into the phone. They have to operate much, much faster at higher data rates. And the amount of DRAM and managed NAND that goes into each phone is increasing. Today with 5G handsets, we see an absolute minimum of 6 gigabytes of DRAM that's needed. And we easily see, 8 and 12 gigabytes of DRAM getting designed into phones. On the storage side of things, if you look at a mainstream phone today, they typically have 128 gigabytes of managed NAND. With the user cases and with these applications that we're seeing continue to emerge and pop up in the mobile space, 128 gigabytes of storage can get consumed in under 2 years. That's faster than the life cycle of the phone. And so we really have to continue to work on introducing more DRAM content and more storage into the phone. And the challenges that we have in doing that, the end consumer expects the phone to continue to operate with the same, days of use, the same battery life that they've historically had, and they expect the same form factor. So we have to pack more performance, more density, and more, better power performance into the same form factor so that we're continuing to enable, those expectations and those same user models that the end consumer has been conditioned to.
And I think that's a point you can't underscore enough, is that whether you realize it or not, there is a lot of AI workload that may be running on your mobile device. As you mentioned, simple things like computational photography, making pictures look a little bit prettier, or maybe taking them when it's very dark outside. We can do a massive amount of things today with software, but it still requires a lot more heavy lifting on the back end, and not just from this phone CPU. I mean, we have to hold the picture in memory as we do the computational pieces on it, and then once they're done, we have to send it to the storage on the device, maybe to later upload to the cloud, who knows. But what happens if that process doesn't execute quickly enough? Users are notoriously impatient when it comes to, I want to take a whole bunch of pictures right now. And if the system is sitting there trying to process it as quickly as possible, they don't necessarily get the performance that they're expecting. I mean, is this something that you have seen kind of borne out in the market of, it's not just that memory and storage have the right capacity, but they also have to be speedy in order to meet the user demands for what these devices are capable of providing instantaneously.
Yeah, you're exactly right, Tom. That the end consumer, if you're trying to capture an image or capture a specific moment in your life, you don't have any tolerance for latency with the camera, latency for processing that image. Once an image has been captured and stored in either the phone or in the cloud, to your point, if you want to share those images or share that experience with a friend or a family member, you want that image to be immediately available. You don't want any latency in getting that image on your phone. And beyond photography and image capture with the phone, to your point, AI continues to creep into many other dimensions of our daily use of our phones, whether it's your calendar or directions. It's trying to predict what you're going to need, when you're going to need it, and make sure that that information is available to you at the very right moment.
It sounds to me like it's almost like trying to look into a crystal ball and project where you think things are going to be without really even being able to tell that difference. And I worry that there are mobile device manufacturers out there that quite honestly think that they've got this all figured out and they're going to be able to do it all on their own, and they're going to focus their resources in the wrong spot. They're going to continue to optimize, say, the processor on the system on a chip without really taking into account the rest of the subsystem that is absolutely necessary for these devices to perform at top speed and with the best performance possible, both from transmission speed, but also from a battery life perspective. And I know that Micron has been doing a lot of work in the industry to kind of bring the players, if you will, together to understand that every system is important. I was wondering if you could maybe speak to a little bit to some of the things that you've been doing to kind of innovate around that and help the device manufacturers, whether they make the whole device or the components themselves, to kind of come together to understand the challenges that are out there.
Tom, I think you make a really good point. If you look at the growing complexity in mobile devices and the needs of mobile hardware, it's absolutely critical that we partner and we collaborate with the OEMs that are developing the handsets, as well as the rest of the ecosystem, the chipset vendors, app developers. We want to make sure that we are fine tuning and really developing the best possible platform possible to manage the amount of data and the data speeds that we're seeing today at Micron, to really make sure that we are delivering the best value possible to the OEMs and helping them solve some of the problems that they'll be confronted with. We've developed a lot of internal systems level capabilities where we can both simulate and validate in hardware what our managed NAND and low power DRAM devices do at a system level, how they solve system level problems, and really deliver value for the OEM and the end consumer. And we think that that's absolutely critical, as we continue to see these growing needs and these growing complexities at a system level. We want to make sure that we understand how our products work, not only at a component level, but at a system level as well.
Yeah, and I think that that can't be underscored, is that the amount of complexity that has to go into essentially a supercomputer in your pocket is beyond the capability that most people to even comprehend. But thankfully, we have great companies like Micron out there who are innovating in their space and trying to make sure that what we see in the future not only provides us with, an effective user experience for all of the applications that we want to use, but is a device that we can continue to use, month after month or even year after year as the mobile world becomes more integrated into our society and our way of life. I know that Micron does a lot of things in this space, and I was wondering if maybe you could tell our audience where they could go to maybe learn a little bit more about what Micron does.
Yeah, absolutely. You can learn more about our products and our technology at micron.com/mobile. At that site, you'll learn about new technologies that Micron has developed and we're leveraging and introducing in the mobile market. We've recently introduced 1-alpha DRAM technology, which is an industry-leading technology, and we've used that for new low-power DRAM products for the mobile market. This is a really important technology for us in that it enables us to increase the DRAM density that goes into a phone while maintaining the same form factor. It also helps us improve the power performance of the device. And relative to previous generations of technology, we're able to improve the power efficiency by as much as 20%. For managed NAND, we're leveraging Micron's leadership position in 176 layer NAND. Again, we were the first in the industry to introduce 176 layer, and we've used that to develop a UFS 3.1 product that increases the speed and the capability of managed NAND in the phone. And again, we're able to use that technology to increase the density of storage that goes into the phone while maintaining the same form factor. So again, Micron's really been in a leadership position with our technology introductions, and we continue to use that technology leadership to the benefit of the mobile market to help us solve the problems that we've been talking about today, Tom.
Well, Ross, as someone who loves to geek out about mobile technologies and try to shop for my next phone, I think what I'm going to do is head over to micron.com/mobile, check out some of the resources that you have available, and maybe make my next purchasing decision based on some of the advanced technologies that you've been working on. So I want to thank you very much for this interview. It's been very enlightening, and I learned quite a bit about the complexity that comes in mobile devices. And for those of you out there who want to learn more about some of the great technologies that we offer here at Gestalt IT and our discussions, we'd invite you to head over to our website at gestaltit.com and just take a look at some of the articles that we've written and some of the videos that we've recorded. And we can't wait to bring you more great technology discussions like the one that I had with Ross very soon.